So if I were to say, Ralph, tell me about Mars dirt, that is a pet peeve.
It's not
because
dirt.
it's not dirt. You don't like the term dirt. It's not accurate. It's called regolith, right?
Right, it's regolith.
And regolith, that's a tough word to say for me. Regolith is like, it's lava rock that hasn't basically come together. Is that correct?
No, it's boy, how do we describe this? It is the material that's on the planet.
Which planet?
Whatever planet. It could
Okay.
or it could be the moon too.
All right,
You know,
okay.
the moon's it's still regolith. It's basically the substrate that's there that doesn't we don't call it soil because there's nothing organic in it. Soil
Right.
by definition has organics in it. So it's rock that has been weathered by radiation, wind.
So it's rock. It's
crushed
broken down.
volcanic rock for the most part.
it's like
but
the
there's
stuff
there's different minerals in it, and things are added to it over time. It's weathered. So I'm not the geologist.
Right.
What I'll tell you, the key about talking about it as regolith and dirt is the fact that people need to appreciate there's nothing organic in it.
Right.
So if I just took a handful of this material and tried to grow plants in it, there are not a lot of the necessary potentially not a lot of the key nutrients in there that is going to be needed. So you would have to augment that regolith with some of the things that the plants would need to grow.
So how do we do that? And I have another question. How do we do that? I know that's a very general question. But B, we don't have any actual Mars regolith.
Nothing from Mars.
We have nothing from Mars. And so we have to simulate
Right.
something from Mars based upon what broken up asteroids or how do we simulate what's on Mars? We don't even have a physical sample of what is on Mars.
All right, so I want to just set one thing in place for you first,
Yeah.
and that is right now we're not sure yet that we're even going to be using that in situ is what we call it, refer to it, in situ resources, that material that's on Mars to grow plants in.
Okay.
It could very well be when we grow plants in small greenhouse settings here and we're trying to develop them for food in controlled environments, we don't bring in soil. We do everything hydroponically. Mm-hmm. Right? So at least for the early missions to Mars, it's probably pretty well expected that we're going to be bringing an adaptation of this microgravity plant growth system that we're flying out on the transit mission, and we're going to tailor that towards surface missions on Mars. So that'll be hydroponic. So the question is, down the road, does it make sense to incorporate that regolith as a potential growth medium substrate?
It seems like
Now-
it wouldn't. Just from a,
Now, it would or wouldn't?
it would not.
Well,
Because what value does it bring to growing plants if
so
it has?
again, I'm not the expert
Either.
in all the technologies associated with this, but one of the things we know about hydroponic systems is if you have a malfunction in a hydroponic system, unless it's a deep water system, it's one that it constantly requires moisture. The plants require air and water constantly in the quantities that they need. So if a hydroponic system, certain hydroponic systems go down, you don't have much time to react before you lose that whole crop.
Yeah.
So from the standpoint of resiliency, reliability, what we do on terrestrial ways, we have different versions of hydroponic systems, but we also look at trying to incorporate a buffer in there, something that will give you margin where the plants will still be able to live and survive until you can get things straightened out. And the regolith might provide a mechanism to use as a buffer in those kind of cases. It could also be, we've had some initial conversations with folks who are designing a large-scale Mars habitat for the United Arab Emirates. They're going to be building one there as an example of what they would like to build on Mars.
Funded by their country or just some rich Saudis?
Yeah, I think what they're trying to do is transition from an oil-based economy to a technology and information-based economy, and they look at spaceflight as cutting edge. So I think it's part of this larger effort. But the key thing is when I looked at some of the architectural renderings of what this habitat would be like, they had palm trees growing, in this. And so a palm tree is going to grow in some...
They love the palm. Didn't they build the islands in sand and make a palm tree out of it?
Well, the key thing
They
is
love
that
the
they're
palm
going
tree
to... Hey,
brand.
one of the things I think we're not good at is when you look at all our space vehicles, they're very sanitized and they're very mechanistic. And part of the effort that NASA has to start looking into, and they're doing this now, is what is the psychological impact of living in these kind of environments for protracted periods of time. So I think when the UAE looks at it, they're trying to make a place that looks more like home. So if you want to talk about growing plants as decorative items or different larger scale plants that may not primarily be food sources. They might serve other purposes. Now you're going to potentially have to be incorporating regolith in some way. So it depends where this goes. This is so far down the road that we can paint any picture we want.
Well, there's a difference between growing something in low Earth orbit, like the International Space Station is low Earth orbit.
I didn't answer your question, by the way.
That's fine. It doesn't matter.
I mean, we can go back to it later.
I don't even remember my question.
Your question was something in regards to what is it? How do I know what the regolith is primarily? How do I know what it is?
Right.
I don't have any, so how do I know?
How do you simulate regolith if you don't have the actual sample?
We have a lot of information from the different landers. We have Curiosity, Opportunity, the different rover missions that were there, even some of the orbital platforms give us data back. So we have a fairly good idea in specific locations what the mineralogy and chemistry is for certain areas on Mars.
Yeah.
So we use that.
I had like 5 questions there too about landing on Mars, but I'm going to wait. So the main difference, 5 of the main differences between growing something here on Earth and growing something in deep space. And it's important, I think, that maybe you educate me and our listeners the difference between low Earth orbit, where the International Space Station is, and deep space, or where Mars is terrestrial. Is it terrestrial space? What do you call that area up there?
What, it's the surface? You mean on the surface of Mars?
Yeah.
So what you have is, in low Earth orbit, we're really nestled comfortably within the radiation belts, the Van Allen belts that protect us from galactic cosmic radiation.
Galactic cosmic radiation?
Yeah.
Yes, that's the
high energy particles that are definitely not good. So when plants grow in Leo, rather than Elio. Yeah.
Leo, sorry.
We don't have to worry about the radiation environment. There's a unique radiation environment, but it's a lot less potentially derogatory or detrimental to the system than the deep space radiation environment. So as I start and I get away from the Earth's magnetic fields and I get away from that protection, and now I'm just moving towards the moon, right? Mm-hmm. Now I'm in this deep space radiation environment. And not only is it radiation, one of the things that there is coming into play potentially is the fact that I'm away from the Earth's magnetic fields. And I've seen some literature recently that implies plants will be affected by the lack of a magnetic field. Some may grow better than others. Some may go really bad. Mm-hmm. Too much early to say that. But we're actually now looking at how do we simulate this radiation impact on plants. We have particle accelerators in laboratories. I know we go up to the Brookhaven National Laboratory in New York to do research. We have a researcher at KSC who I work with who's going up there, and she does exposures of seeds to this radiation beams, particle beams they have there. But they try to simulate that deep space environment. They can't really do it. It's not really an effective simulation. It gives you an idea of what radiation exposure could do, but it's not as accurate as really in the environment. So for us, and not just for plants, but for the people aspect, the human health aspect, the health of the crew, we need to get time in that environment. We need to do a lot of research there to see what's the effects in that environment. We can do things like shield vehicles for people, but that's a whole complicated issue too. So we need time in that environment, which is different. And once I get towards the surface systems, now I have the ability potentially to dig underground to get away from some of the more hazardous radiation. I think that from what I've heard, probably the worst radiation is in this area, cislunar space. It's the area between the Earth and the moon. That's probably the worst because it's closest to the sun. When I start going to Mars, I'm getting away from the sun. So I'm losing some of the impact of the solar radiation. I still have the galactic cosmic radiation, but where we are now is probably going to be the worst.
That's a good point. Let's talk about how, since you're further away from the sun, and one of the things that plants need is sunlight, and I think it says that it's like 43% less sunlight on Mars than there is on Earth, and then that's not factoring in all the dust storms that occur frequently. How do you solve that element of growing plants on Mars when it comes to lighting?
So when it comes to lighting, technologically speaking, we could use sunlight. Even if I had a space station up orbiting around the Earth, I could use sunlight and I could pipe it into the vehicle and then distribute it as a light source for plants. There's the technology issues associated with now I'm penetrating the pressure volume of the vehicle. It was very challenging just getting a cupola up on space station with glass and windows. To actually put something through that will allow me to capture that radiation. There are people who's demonstrated that it's possible. We did it at the Kennedy Space Center. So it's a realistic thing. It's just that there's kind of not necessarily at this point a need to do that. So we basically have defaulted to the lighting technology, and that's where indoor farm and greenhouses basically have really advanced the technology of LEDs.
But you talked about hydroponics going back. Hydroponics requires water, obviously. Water how does water react to in low Earth orbit and then in deep space as it pertains to plants? Because we know it kind of like goes around the surface of a root.
The biggest challenge we have in microgravity plant growth is managing the delivery of air and water to the root zone of plants in the ratios they need when they need it.
Yeah.
That's the biggest challenge, is that two-phase air and water in microgravity issue. There's a couple of interesting photos astronauts have taken, one where there's a big ball of water and inside there's a ball of air, and they just they don't play
nice.
They don't play well together. So that's really the biggest challenge we face right now.
Now, every time you say the biggest challenge we face in LEO, that's not solving the problem
and that's microgravity. So
right.
That's all the way to Mars. Once you get on the moon and once you get on Mars, there's still gravity there. You know, Mars is about 38% gravity of the Earth, and the moon is like 1/6. It doesn't mean that the problem goes away, but now there's a root zone, and water basically is affected by that gravitational field. We'll have to see when we get to the moon how much of a field we need before we can actually solve the problem. There's been some debate about that I've heard recently, but in microgravity, it's a big challenge.